Good day and welcome to today's class on set. Today's class is a continuation of our previous classes on Introduction to Set. In today's class, we shall be looking at the following objectives. We shall learn what we mean by elements of a set. We shall look at the types of sets and the cardinality of a set. At the previous class, we were able to look at the definition of set, where I defined set. Set can be defined as a group of well-selected items based on specific characteristics that differentiates them from others. We also looked at set notation, where I gave you the different notation used in set. As a reminder, I told you that set can be represented using capital letters A to Z. We also looked at the description of set, where I told you that sets can be described using word description. We have listing stating a rule and the diagrammatic representation of set, which I equally said is said to be Venn diagram. In today's class, we shall be looking at the elements of a set, types of set, and the cardinality of a set. Elements of a set are said to be the members of a set. By elements of a set, we mean those members that meet those specific criteria that was given in trying to define that set. For example, we have a set of students in SS1A. By saying a set of students in SS1A, we have given the description of that set, meaning if you don't belong to in SS1A, you cannot be found in that set. Elements of a set can be said to be, example, if we have a set A to be a set of small letters A, B, C, and D, they are said to be members of that set. Elements of a set are said to be written in small letters, being separated using the comma and enclosed in a curly braces. Elements of a set can be denoted using the symbol this. For example, I'll say A is an element of set A. So we use this symbol in showing that small a is an element of the big A. Under types of sets, we shall be looking at equal sets. Two sets A and B are said to be equal if all the elements in A are contained in B. For example, if I have set A to be equal to A, B, C, D, and another set B being equal to A, B, C, D, these two sets are said to be equal because all the elements in A can also be found in B. Also, we have an empty set. A set is said to be empty if it contains no element at all. An empty set can be denoted using the symbol phi or just the two curly braces without any element in it. A universal set is said to be the set of elements, all the sets of elements under consideration. For example, a set of students in St. Patrick's College. St. Patrick's College is referred to as the universal set because it is said to consider all the students in St. Patrick's College. And the universal set can be denoted using the symbol U or sigma. Coming to subsets. Subset of a set is said to be a fraction or part of the universal set. I give you an example. If you have a set A to be made up of alphabet A to Z, a set B can be said to be a subset of A if all the elements in B can be found in elements in set A. For example, if a set B is said to be a set of vowel sounds, that is A, E, I, O, and U is said to be a set B, the set B is said to be a subset of set A. Why? Because all the elements in A in B can be found in A. So we refer to B as a subset of A, and it is written as B is said to be a subset of A. So this sign shows you that B is a subset of A. We also have the finite and infinite sets. A finite set can be said to be a set that contains elements that are countable. For example, the set B is said to be a finite set because it contains elements that are countable. For example, this set B has 5 elements and it is said to be a finite set. While set A, being a set of alphabets, these 3 dots placed at the end of it indicate that it is an infinite set. Although we know all the letters of the alphabet to be 26, but whenever you have a set with 3 dots at the end or before, it shows you that that set is an infinite set. For example, a set of natural numbers, a set of real numbers. Since all these numbers cannot be counted, we refer to them as infinite sets, and they can be represented using 3 dots at the end of it. For example, we have 1, 2, 3, and the 3 dots. These 3 dots indicate infinity. It shows you that you have more and more elements of this set that cannot be counted. We also have an equivalent set. 2 sets are said to be equivalent if they contain the same number of elements. For example, we have set A to be made up of 1, 2, 3, and 4 elements, while set B has elements A, B, C, and D. For the fact that in set A we have 4 elements and set B equally have 4 elements, set A and B are said to be equivalent. And we represent that using the sign A is equivalent to B. A is equivalent to B doesn't mean A is equal to B. I gave you an example of equal set, that 2 sets are said to be equal if all the elements found in A can be found in B. While in this example, we can refer to set A and B as being both equal and equivalent, but under equivalent sets, these 2 sets are said to be equivalent but not equal. So for 2 sets to be equal, they must have the same number of elements, and those elements must be alike. We look at cardinality of a set. The cardinality of a set is said to be the total number of elements in that set. For example, if S is defined as whole numbers greater than 11 and less than 19, we are asked to find the cardinality of the set. By cardinality, we can denote it using n of S. N of S means cardinality of a set. So that if S is defined as whole numbers greater than 11 and less than 19, the cardinality of the set now becomes, let's first of all list out all the elements in that set. Set S is said to be made up of whole numbers greater than 11, that includes 12, 13, 14, 15, 16, 17, 18, because it says greater than 11 and less than 19. So these are the numbers greater than 11 and less than 19. Why the cardinality, we call it n of S, is said to be, you can now count the number of elements in that set, and that gives you the cardinality. So the cardinality of S now becomes 1, 2, 3, 4, 5, 6, 7, which gives us 7. So therefore, the cardinality of set S is said to be 7. Let's take more examples. That if A is equal to a set of elements 2, 4, 6, 8, and B is described as a set X such that X is a positive even integer less than 10, what is the relationship between A and B? For us to get the relationship between A and B is to list out the elements in B. Thereafter, we'll compare it with A and see if we can get any relationship between them. So set B is described as positive even integer less than 10. Positive integer means positive whole numbers that are even. So that includes 2, 4, 6, 8, less than 10. So I will say set A is equal to set B. Why? Because all the elements in A are same as the elements in B, and their cardinality is said to be the same. Example 2 says, which of the following sets are equal? Which of the following sets are equal? Now, set A has elements A, B, C, D. Set B has elements B, C, D, A. Set C has elements C, D, A, B. And set D has elements D, C, A, B. Now, looking at all of them, you will agree with me that the cardinality is said to be 4. They all have equal cardinality. And the elements are also equal, irrespective of how they are placed. They all have A, B, C, and D. So I will say that the sets A, B, C, and D are said to be equal. That is, A is equal to B, is equal to C, and C is equal to D. That means the 3 sets are said to be equal. Example 3 says, which of the following sets have the same cardinality? By cardinality, we mean number of elements in that set. Set A has cardinality of 4. That is, n of A is equal to 4. N of B is also said to be 4. And n of C, how many elements do we have in C? C also have Makudi, Otukpo, Otupa, Ikom, and Apa. N of C is said to be 5. So, by this, we said n of A and n of B are said to be equal. So they have the same cardinality. So it is n of A and n of B. We said A has the same cardinality as B and differs from C. Let's take examples on empty set. Now, which of the following is an empty set? A, months beginning with A. B, months beginning with K. C, days beginning with S. A, that which of the following is an empty set? Do we have months beginning with A? Yes. August is a month of the year beginning with A, so that is not an empty set. Set B, month beginning with K. Month beginning with K is an empty set because it contains no element. We don't have a month in the year beginning with K. Set C is defined as days beginning with S. We have Saturdays and Sundays. Okay, so this is not an empty set. Just B that is an empty set. Under equivalent set, example, we have set A, which has elements boy, girl, and man, and set B has elements A, B, and C. These two are said to be equivalent sets because their cardinalities are said to be the same, which is equal to 3. So I said n of A is equal to 3 and n of B is also equal to 3. So we have it that they are said to be equivalent sets. The universal set is a set that contains all the elements under consideration. That given the set 9, 10, 11, find all the possible subsets. I defined subset to be a fraction or part of the universal set. So if this set is defined as A to be 9, 10, 11, all the possible subsets of this set can be said to be 9 is said to be a subset of the set A because it is a fraction of set A. 10 is also a subset. 11 can also be said to be a subset. We equally have 9, 10 can also be said to be a subset. We equally have 9, 11 as subset, and we equally have 10, 11 as subset. Remember, empty set is also said to be a subset of every set, and also a set can also be said to be its own subset. So we have 9, 10, and 11 as the subset of set A. So therefore, all the possible subsets of A are said to be 1, 2, 3, 4, 5, 6, 7, 8 in number. So we have 8 possible subsets from a set of 3 elements. Example 2, if you have a set A to comprise of elements Jos, Otukpa, Oukpa, and Ohimini. Set B is said to comprise of elements Otukpa and Oukpa. We are asked to draw the Venn diagram to show this information. If you are to draw this, I would have this, since B is said to be a subset of A, I'll have to draw this to be a set B. Let me call this set B. And set B is said to be made up of Otukpa and Oukpa. Since set B is a subset of set A, I can now draw set A as a universal set to be made up of Jos and Ohimini. Now, since B is also a subset of A, this is the best way of representing it, showing you that set B only contains Otukpa and Owukpa, while set A contains Jos, Ohimini, Otukpa, and Owukpa. So this is how to draw the Venn diagram to represent this information. We look at power set. Power set is said to be the number of possible subsets in a set. The number of possible subsets in a set. Example says, if A is equals to A, B, list all the subsets of A. All the subsets of A, we refer to it as power set of A. We represent it using P of A. This is equal to, remember I told you that an empty set is a subset of all possible subset of all sets, and we also have set A as a subset. I also have set B as a subset, and A, B. So P of A is said to be 4 because I have 4 elements, 4 possible subsets, sorry. 2 says given N to be a set containing elements 1, 2, 3, what are the possible subsets of N? The possible subset of set N includes, we'll call it P of N. P of N is equal to an empty set. We have 1, 2, 3 alone. I equally have set 1, 2 as possible subsets. I have 1, 3. We equally have 2, 3. And I have set 1, 2, 3. Which other one do we have? Okay, 1, 2, 3, 4, 5, 6, 7, 8. So these are all the possible subsets of set N, which we refer to as the power set of N. So therefore, P of N is equal to 8. That brings us to the end of today's class. In today's class, we were able to look at the elements of a set. We were able to do justice to the different types of sets, and we were able to look at the cardinality of a set.